Assalamualaikum warahmatullahi wabarakatuh. My name is Rizqy Pratama Singarimbun from the morning class I robotics. Here I will present a presentation about a Kalman filter. So we are wasting more time with time. We start. Okay, firstly, what we will discuss in this presentation is what is Kalman filter and how does it works. So before that, I would like to introduce you to someone. His name is Rudolf Eckelmann. Rudolf Eckelmann is leading scientist in the fields of control engineering and statistics, and continues to make significant contribution to the development of methods and technology in various related fields. He has received more numerous awards, including the National Medals of Science in the United States in 2008. Rudolf Eckelmann passed away on July 2016. He is a science and engineer known for his contributions to the fields of controls theory and statistics, particularly in the development of the Kalman filter. So this guy is basically the who are the one who is development the Kalman filter we will be discuss. So next, what is Kalman filter? Kalman filter is a mathematical method used to estimate and predict unknown value based on the imperfect or noisy measurements. So, for example, we have a moving object such as a vehicle, and you want to track its positions. You have measuring device such as GPS that provides you a position data for the vehicle. But this data often inaccurate due to disturbance and uncertainty in the GPS signal. Common filter will help you predict and correct the position of the object based on of inaccurate measurements data. But how does it works? So, firstly, in the phase of prediction, you will start with initial estimate of the object positions and initial estimates of uncertainty as far you know is accurate. So you also have a model that describes how the object moves over time. The Kalman filter uses this model to predict the object next position. Next phase is a measurements where the measurements you will obtain a measurements data from your instruments such as GPS data. However, is that this data is not always accurate. The Kalman filter takes this measurements data and consider how far it is from the previously made predictions. Next phase is a correction based from to that the prediction and measurement data. Common filter will provide you a correction to your position estimates and uncertainty. This means the filter will give you more weight to accurate measurements and less weight to the inaccurate data. You can see here for the first time the gap between red and black wire. The line where is the red is estimates from common filter and the black is real positions. For the first time, the gap between two lines is fixed, but after several times, the gap between them became between more or less from the first one until you come near to the real positions and narrow it to become the close to position ground of truth. So next, how does it works? So firstly, we have three main equations. First one is calculate the Kalman gain, calculate current estimates, and calculate new error and estimates. In the first equation, we need a error and estimates, but we for the first time we can initial it with original error estimates, and next we also need error in data measurements. The output will be used in the equation number 3 and equation number 2. And next we're moving to the equation number 2, where is calculate current estimate. So we'll calculate a current estimate position. That we need a previous estimate, but for the first time we don't have it. So we can initialize the initial original estimate or the first time position estimates. Next, we also have did a measurement value from a data input, and the output will be used in the equation number 3, where we moving to equation number 3, we calculate new error and estimates. The output will be used for the next iteration, will be replaced value error and estimate where we first time initiate. So we don't use the first time initiate, we order the output from the equation number 3 for the next iteration. And also in equation number 2, the output will be the update estimates position that show us where is the position of the robots. So this process will keep repeating when we get a new data and predict our new positions close to our real position or original positions. So that's all about my presentation. Thank you for your attention. Good morning.